Traffic flow. In this video, we are concerned with transit traffic. That's traffic that's intended to be forwarded to a particular destination, not exception traffic, which is intended for the device itself. Transit traffic is entirely the domain of the packet forwarding engine and not the routing engine. So you get great performance in terms of packets traversing the device. Flow-based processing. Imagine for a second that you're a device and you have to inspect the details of each packet as it arrives. The more detailed that your inspection has to be, for example, stateful inspections, NAT, IPS, Unified Threat Management, and so on, the longer it's going to take, right? This will likely slow your processing down, which is the case, for example, with SRX Security Services gateways. So, to speed things up, you would likely look for easily discernible patterns, and that's sort of what flow-based processing does. Flow-based processing is performed once packet-based filters and policers have been applied to a packet. So a flow is a stream of related packets. The packets are related by virtue of the fact that they have the same matching criteria under processing and that they exhibit the same characteristics. That's the pattern, if you will. This diagram is an abstract view of how flow-based processing happens on a Services Processing Unit or SPU. All flow-based processing for a particular flow happens on one SPU. Remember that. Okay, so the first packet of a flow arrives. Configuration settings like applicable security policy, application layer gateway requirements, network address translation if required, they get evaluated for this packet. A session is created for the first packet to store the security actions that will be applied to subsequent packets of the flow and to cache state information concerning the flow. So, to determine whether a flow really does exist, a Network Processing Unit, or NPU, sees if there is a match between the packet's information and an existing session based on source and destination addresses, source and destination ports, the protocol that's involved, and a unique token for the session, which is itself based on zone and virtual router data. If there is a match, the NPU sends the packet along with its metadata to the SPU that was assigned the matching session, known as the fast path. It's the short path in this diagram. If no match, the NPU sends the packet to the central point who assigns session processing to some other SPU, shown as the other path in this diagram. This type of processing improves the performance of security services gateways by effectively eliminating the necessity to make packet-by-packet decisions. Packet-based processing on the Junos operating system occurs on packets between the input interface and output interface queues that it traverses on the device. Each packet is treated discretely. You can also refer to this as stateless packet processing. To further clarify, you should know that each packet is assessed individually. So, stateless packet processing pays no regard to previous flow or state information, as it were. It doesn't need to. I mean, that is to say that previous or subsequent packets that belong to a given connection are not considered in any way when processing the current packet. This is a high-level rendering of packet-based processing. As packets enter the device via the input interface queue, any filters, policers, or classifiers get applied to it. After a route lookup, output filters and shapers are applied. Then the packet is sent to the output interface queue, where it is now ready to be transmitted on its journey to its destination. So, in this video, you saw how flow-based processing and packet-based processing takes place on the Junos operating system.